morning, ma'am.
Good morning.
Yes, we are live.
Should I begin?
Sir, we will start at 10 o'clock. Just 1 minute is left. Ma'am, can we start?
Oh, yes. 1 minute.
Yes, yes. Good morning, everyone. Welcome to our webinar on cloud computing. I request Mona Madam to give the introduction speech.
Good morning, everyone. I, on behalf of SWS College, take this privilege to warmly welcome our Principal Ma'am, Dr. Usha Iyer, Vice Principal, Mr. Asif from Vidyalankar School of Information and Technology, our Coordinator, Professor Suchita Revankar, Technical Team, Mr. Nikhil, teachers and all participants. I welcome you all to the one-day webinar hosted by Department of Computer Science. Cloud computing is on the demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on the needed basis for a cloud provider. So the topic of today's webinar is cloud computing, platform, development, and applications. It takes a great pleasure for me to introduce our speaker of the day, who will be talking us about cloud computing. We have with us eminent speaker Mr. Asif Rampurawala, who is the Vice Principal of Department of Information Technology, VSIT. Highly analytical, result-oriented professional experience in the field of technology. A perfect blend of technical, analytical, and business skills. I welcome you, sir. Now, I request our principal ma'am, Dr. Usha Iyer, to give the welcome address.
Very good morning to one and all. Can you all hear me?
Yes, ma'am.
Yes,
Yeah.
ma'am.
It's a matter of privilege, pleasure, and an honor for the SIWS to have Mr. Asif Rampurwala with us, Vice Principal of the Vidyalankar Institute of Technology. I am very all the more happy to the catchy title cloud computing platforms development and applications, which is very very relevant for all, not only the CSIT students. Although I may be a quack, I understand it's a knowledge about web based services or virtual resources that enable us to have a control over data and services. How relevant this topic could be in the modern day where we are worried about our own data, the security part of the data, and the flexibility of the data, the quick access to the data, the analysis of the data, the agile businesses which we can conduct with these data. Wow, Asif, the topic itself is too good. And I must congratulate the Department of Computer Science and IT for embarked upon this topic for very many people like me who are quacks in the field. And as far as I know, Asif, in the short time of interactions I had with him, is not only an educationist but a technocrat and also a versatile leader with a ready smile, ear to ear, and head for strategy. I'm amazed by his passion to do things to the best of its ability, and I found him very capable, confident, fluent, and never at loss for words. I also appreciate the background of the knowledge he has in the field of subject because me and my management were too happy to have him as a resource person in one of the panels. Thank you for being with us, Asif. It is a great pleasure for us to have you. I thank you on behalf of the management, me, myself, and of course the department. As for the students, you rarely get such occasions other than the regular teachers. So please interact and get to know more and more things because this is the field which is going to be very, very employment oriented. And I wish you all listen to the talk, be curious to ask questions, and expand your mental horizons. Thank you, one and all. Thank you for being with us. Congratulate the department, and of course, Asif to be connected to us always. Stay safe, stay connected, stay healthy and happy. Thank you. Thank you, Asif.
Thank you, ma'am. Thank you for your such kind words. I always, whenever I visit SIWS and I meet you and your staff members, I'm truly always, the warmth and the love which I receive is, I must say, I appreciate it a lot. So therefore, when Mona ma'am again asked me this time to, Assessor, would you want to take up a topic on cloud computing? I said I would love to, because rarely do I get a chance to interact with also the students. Now, when we were having these interactions, and the topic of cloud came up quite a lot as well, and I must say it's probably a very relevant topic even for students who are at the undergraduate level. And today's talk, I have tried to put in things which are both slightly at an bird's eye view level, as well as uh, giving some technical information as well, which is possible, in the limited time period which I have. However, the most important thing which I think will be is the interactive session. If you have any questions, students, please feel free to put your questions in the comments, and we would try to take those at the end. I have specifically kept some time for that interaction because I love to interact rather than do a monologue where I keep blabbering, which may or may not be useful sometimes. So as ma'am said, she put it in a nice way when she said that I'm not at loss of words, but I may suffer from a verbal diarrhea, as according to some of my friends. So I don't know when to shut up. So the organizers are most welcome to indicate to me whenever the time is whenever I'm reaching my limits of the time. So that's a given. I don't mind that at all. If somebody just indicates to me that we are towards the end of the session, that's absolutely fine. So let me begin by sharing with your kind permission, ma'am. Can I start the presentation?
Yes,
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 sir.
sir, please.
Just to confirm, if my screen is visible.
Yes, sir.
All right.
It's visible.
Yes. So when people talk about the cloud, the first thing, earlier there used to be this conjuring of maybe computers in the cloud or in the sky, which is not the case now. Whenever people talk about the cloud, the first image which comes to mind are data centers. This is a small image of a real data center which is operating with uh, hundreds of servers, maybe thousands of servers, terabytes and petabytes of storage, huge bandwidth, a lot of infrastructure to maintain this kind of computing facility, both physical infrastructure and human infrastructure, as we call it, the human resource which is required to maintain also. All of that makes what we as laymen, as users of the cloud, refer to the cloud as. So this is where the heart of the cloud resides. It's in the data centers. So whenever we store a file or whenever we use an application on the cloud, what's happening is somewhere there is a data center just like this, which is doing all the work for you to deliver what you see on your mobile phones or your tablets or your computers. Today, the very fact that I'm coming to your homes in your mobile phones and in your tablets or in your computers and talking to you has been made possible because of the cloud platform itself. I don't know if we would have been, let's say, 20 years ago, if the pandemic had struck us like this, I don't know what would have happened to the entire concept and of education. Today, we are able to call this a new normal because of the cloud platforms which are available to us. Without the cloud, it would have been truly difficult for teachers and students to connect and to continue the education and learning, which should not be disrupted by this pandemic. Today, when we look at these various cloud applications, as students of computer science or IT, I would truly request each one of you to try and understand what we are going to discuss today and identify topics which you would want to study more in detail. And maybe if you are in your first year or your second year or even your final year, you would want to take up as a project, which would then lead to many doors opening, whether that would be in terms of placements, internships, or masters research avenues. There are n number of opportunities available in this area, and many of the times students or parents, when we are doing admissions, they ask me, sir, is फील्ड का स्कोप क्या है, मतलब आईटी में आते हैं या कंप्यूटर साइंस में, when they are taking admission, do you think this is the correct line, as we call it, is it a correct field where I'm putting my son in? And when they come into the system, they ask me, what can I do for my child? What technology should I encourage them to study more, or what? Many people talk about languages like Python and courses like data science. But what I have realized is many students do not really understand where is it all going to be used. So if you learn a language like Python, or you study the topics of data science or data analytics, what we truly do not understand is where is it all going to be used today. And today all of this is not possible without the power of the cloud. So Python is used as a language to do cloud development, to build applications for the cloud, to allow data driven applications to be run over a cloud. Data science or data analytics is truly made possible today. Why is it something which we discovered now in the last 5 years? Absolutely not. We have these algorithms of how to analyze data for decades now. Yet suddenly the as Principal Ma'am rightly said, we're talking about data. All of this data is now becoming useful because we are able to process this data. And why are we being able to process this data now, and what we were not being able to do before? Is the difference is the availability of clouds to us. So now let's start off with a very basic question, which always is the most important one to answer, is what is cloud computing? Now, cloud computing, according to me, whenever I talk about cloud computing, the one line definition which I give is that it transforms IT infrastructure into a utility. Now, what do you mean by a utility? So, for example, you pay utility bills at your home and in your offices. Your parents would be doing that. So at home, what are the utility bills which you pay? So utility is electricity bills which you pay, the water supply bill which you pay, your internet bill which you pay, the your television, cable TV or dish TV or whatever your like Tata Sky or whatever you use to bring television services, Netflix, all of these kind of subscriptions which you do, where you have to either pay a monthly amount or a pay per use. So for example, in electricity, whenever every month you get a bill and you pay for the amount of electricity which you use, or when you buy a pack on your cable TV from your cable TV operator, or from this Tata Sky or Dish TV or whatever DTH subscription you have, you pay for the package, for the channels which you are subscribing to, or you pay the internet service provider either according to a fixed monthly plan or according to the amount of MB or GBs which you have consumed. What you are doing is you are using services and paying only for the services which you use, or as much of the services which you use. Now, can I take this subscription model or a utility model and apply it to IT infrastructure? So over the years, companies had to invest heavily in computing hardware. So for example, in your college, I've seen you have labs where there's so many computers are brought in. Now these computers, over a period of maximum 5 to 6 years, become obsolete, and they have to be replaced by the latest technology. So every time, what happens to this old hardware is that it becomes e-waste, and new hardware has to be bought. Why? Because the new software, the new syllabus which comes into your curriculum requires better hardware to run. So I remember when I started my undergraduate studies, we used to use something called as Pentium 1 processors, okay, which had a speed of something like 200, 300 megahertz. We didn't have the concept of a multi-core processor or GBs of RAM. We used to use something like 32 MB of RAM or 16 MB of RAM. Some of our computers even had 16 MB of RAM. Today, you all have computers of 16 GB or 32 GBs of RAM when you want to, at home. If you're using a gaming machine or a gaming laptop, you might have 16 GBs or 32 GBs of RAM in your. Sometimes I've seen mobile phones now having 12 GBs and 16 GBs of RAM. Now imagine I was not in college 50 years ago. I was in college maybe 22, 23 years ago, and within that span of 2.5 decades, we've gone from MBs to GBs in RAM. We've gone from hard disk space of a few GB, like 2 GB or 5 GB, to terabytes, 2 terabytes and 5 terabytes of hard disk space in a normal computer. Now, when I take this to servers, so companies do not only have to have computers for their employees, but they also have to invest in servers. And servers are more expensive. So we have the concept like mainframe servers and all of that, which is infrastructure which is very, very expensive to buy. Now, when a company has to invest, they need to look at the future. That means, am I going to be able to not only satisfy the demand of today, but am I also being able to take care of the demand of the future? So like 2 years from now, 5 years from now, is this server going to be working for the kind of requirements which I'm going to have? It is going to satisfy those requirements. Now, many of the times, because of this, companies have to do a very heavy investment upfront, making sure that the hardware which they buy lasts for 3 to 5 years or whatever is their window which they have created. With cloud computing, we take away all of this. You don't have to buy very, very expensive servers. A server can cost anywhere between 15 lakhs to even a crore or more, depending on the kind of servers which you're buying. And if you are going to have high-end servers, it's going to be very, very expensive. Now, what if it's a new company who wants to start? Okay, if you want to start a startup, would you want to have to invest in crores or in lakhs on a server? And the answer is no, you don't want to, and you don't have the money to do that. The advantage is that cloud will allow you to buy servers using a concept called as virtualization. So in a data center, they will virtualize the server for you. So you will get a virtual server which you can use to run whatever applications or softwares or whatever data or whatever you want to do without having to buy it upfront. You will just pay for the usage. So this allows you to plug into the infrastructure via the internet. You don't need to, have very, very expensive equipment. You can use a normal laptop and connect to the infrastructure via the internet. So today, to deliver this lecture, a media server is required. A media server which will, send video from my machine to, these hundreds of machines where you all are watching this video from. Instead of using a media server, we are using YouTube, the server of YouTube, to plug into and send this video streaming across to as many people as who want to connect and watch this. So I don't have to worry about whether my server will be able to take up the load, because YouTube server will be able to do that much better than any server which I can buy. So it provides computing resources without doing any installation and does not require me to maintain these servers. So I don't need to maintain the YouTube server now. The YouTube will maintain its own servers. I don't have to worry about whether it will be available or not available in the middle of the night. I don't have to worry about who will switch on the server or switch it off. All that is the headache of somebody else. And I can just use as much as I need to by paying a subscription fee, a small amount of money. Now, this is what makes cloud computing versus traditional on-premises IT far more, relevant and important. Now, traditional on-premises IT means you buy IT infrastructure like computers, servers, networks, and maintain them yourself. But when you use a cloud, the cost of IT infrastructure reduces drastically because you don't have to maintain them and you don't have to purchase them upfront. You just have to pay a subscription. Okay, so you pay for what the amount of usage you do. And the most important aspect is that it allows me the flexibility of moving from one place to the other without having to be tied down to a place. In today's day and age, lots and lots of IT companies have moved to a completely work from home environment. They could do this without worrying about any problems because of the cloud investments which they had done before the pandemic. Companies who had not made that investment or who were not adapting the cloud technology in the last 12 months have been forced to go there and have been forced to use cloud, because without it they would not have had business continuity. They would not have been able to be in business, be able to do their work unless they allow employees to work from home. And now when you want to allow employees to work from home, there is limitation in what you can do using a telephone. You have to use IT infrastructure to get work done. So whether we are taking lectures from home or whether your parents are managing their office work from home, all of this has been possible because of the agility, the flexibility which cloud gives us. The most important thing is it does not require too much of time. So even if companies didn't have a cloud investment before the pandemic, they could easily move their operations to the cloud by just paying a subscription cost. So time to value. So if I would have had to buy my own servers, I would have had to, do negotiations, get quotations, then pay the advance, get the delivery, do the installation, deployment. These processes generally to buy a server and to make it up takes months. But if I want to buy a virtual server on a cloud, I can do that in minutes. And that time to value is highest because of this cloud paradigm. Another very important aspect why people choose cloud infrastructure today as their first preference over traditional infrastructure is because they provide scalability. So they allow organizations to use as little or as much of the resources as they need. So they provide, so majority of the cloud service providers, and we will talk about who are these cloud service providers, they provide something called as on-demand services. On-demand services means that when there is a greater demand, automatically more computing resources will be made available for your applications, thereby allowing you to scale and yet be cost effective. So when this demand is high, it will give you more resources. When the demand is low, it will give you less resources and only charge you for the resources and the amount of time you use those resources. Let me give you an example. Earlier, agar aapko yaad hoga, so there used to be this scenario where we used to log in to check our results, board ke website pe ya whatever websites were there, whenever this online. So having our results online is not a new phenomenon. But one of the major problems which everybody used to face was that whenever everybody logs in to check the results, the server used to crash. Okay. Now imagine The same scenario when we try to book a Tatkal ticket in IRCTC website. Now, the number of people who are trying to access the IRCTC website is huge. And they are able to do this without having any delay or any problems is because of the cloud. When these services were made available for the first time, there used to be a lot of trouble because they were using their own on-premise servers. In the railways, they had bought their own servers. Soon they realized that their servers would not be able to handle the traffic during the Tatkal period, that 10 to 12 a.m., whatever it was the time at that time, that when the Tatkal booking window used to open online, there used to be such a mad rush that it would just clog the entire website. They learned from it, and what they realized was that when they moved towards the cloud, and once they moved to a cloud, they have now been able to handle this much better without customers facing, a crash of the website every time the Tatkal window opens. So that has been the most cost-effective and easier way to scale for any company, whether it's a government big company like the Indian Railways, which is one of the massive enterprises, or when it comes to a small, new upcoming e-commerce platform. So many of these new upcoming e-commerce platforms have been able to scale so fast because of the cloud. Okay, I'll give you an example. Nykaa.com. So all of you are young. Many of you all might have visited Nykaa. So Nykaa was started as a project, but when Nykaa was as an e-commerce platform, it used the advantage of using a cloud was that they were able to scale very easily. So when they had 100 customers, they had to pay very less amount of money because 100 customers would use very less resources on the server. But when they had 100,000 customers, they were able to make sure that the website is able to handle that kind of a load without having to crash. Okay. I remember, many years ago when Motorola came back to India to launch its mobile phone called Moto G. That was the first. There was a period when Motorola was not in India, and Motorola came back with a smartphone called as Moto G. And on that night when the sale started, the entire Flipkart website crashed. And that was a major news, and it crashed for like 2 hours, and after 2 hours the website was back up. And that was a major news because cloud platforms do not generally crash. And there was a lot of discussion about what were the reasons and all of that, which we can discuss, but probably for some other time. The 5 characteristics that define cloud computing are following. First, on-demand self-service. That means computers, these resources which are available to you as a user or as a user of the cloud, you will be able to use the resources on demand. Okay, so we are familiar with on-demand video. So with the examples of Netflix and Prime Video and all these various Hotstar, we are now familiar with on-demand video and on-demand programming. That means you don't have to wait for a Monday evening 9 p.m. for that favorite show of yours. You can watch your shows when you have the time. Exactly the same can I use my computing resources when I want to use them, okay, and as much as I want to use them. And that is exactly what characterizes a cloud. It's on-demand service. The second one is ubiquitous network access. Ubiquitous network access means you can access your servers from anywhere. That means you can access your servers from sitting inside an office, or sitting at home, or while traveling in a train. You will be able to access your applications, your data, your services without having to worry about where you are. Earlier what used to happen, companies used to have their servers in inside their buildings, and only within the building you could access your softwares or whatever the company's applications were. Today, it can be done from anywhere, which is precisely the reason why work from home has been made possible for people. The third one is resource pooling. Now, how does cloud computing provide cheaper alternatives for people to use infrastructure compared to buying them? ये सस्ता कैसे हो जाता है? It is because we are doing a resource pooling. In cloud, we have thousands of servers running together, but the basic logic is that they are being used by multi-tenant systems. Multi-tenant systems means that one server, physical server, is divided into multiple virtual servers. And many people are sharing that server or those resources. And when somebody's demand increases, more resources are allocated to that client. Why? Because statistically, not everybody needs all the resource at the same time. So suppose there is bandwidth of, let's say, 1 gigabits per second. Not everybody needs 1 gigabits per second every moment of the day. So when it allows us to pool the resources and share these resources, thereby bringing the cost down. When I buy a dedicated lease line, the entire 1 Gbps is reserved for me, and therefore I have to pay a very big amount of money to keep that reserved line with me. But when I share my resource, that is what happens when you buy a home internet connection. You get a 1 Gbps line or a 500 Mbps line or a 100 Mbps line or whatever bandwidth you want, but it is being shared. So you have the fiber optic which comes to your building might be 1 Gbps or 2 Gbps or even more capacity, and then gets shared between the households in your building, thereby bringing the cost of internet service to you far more affordable. Okay, it brings them down a lot. At the same time, it provides rapid elasticity. Now, these are some technical words which we use in cloud computing. Elasticity means another word for scalability. It allows me to use more resources dynamically at runtime without having to do prior allocation. I don't need to reserve space prior. जब जरूरत पड़ेगी तो I will use more space on the hard disk or I will use more computing resources as and when the need be, automatically. And that is called rapid elasticity, that you don't have to worry about that, oh, from one, right now you are using 10 GB of hard disk space. Now suddenly if you needed 1 terabyte, automatically it will be allocated to you, no problem, on the fly. And the last but most important thing is, it is all a measured service. जैसे आपके घर में जब आप सारे पंखे या फैन बंद कर देते हो, AC बंद कर देते हो, गीजर बंद कर देते हो, your meter becomes very, very slow, or even it can stop if everything is closed. When you switch on your AC in the summer, suddenly your power consumption increases. When this increases, you are going to be charged more. How do you know that how much of electricity bill you will get? That depends on a meter out. So in your building or outside your house, there is a meter provided by the electricity supply company, which measures how much electricity you are using daily, and every month generates a bill. Similarly, in a cloud computing environment, especially if it's a public cloud, your resources which you use, whether it is the network, whether it is the storage, or whether the processing power, that is the computing, we say, whatever you use, all of that is being measured by a virtual meter, so to speak. And accordingly, a bill is getting generated for you. And when you, at the end of the month, or whatever is the time period which has been negotiated with you, you will get a bill which you will have to make a payment for. Or sometimes it is prepaid. So you put some money into the account, like your Tata Sky, you put that money into the account, and then for 30 days you are able to use it. अगर उसके पहले वो पैसा कुछ आपने खत्म कर दिया तो फिर आपको recharge करना पड़ेगा. So it could be either ways. It could be either prepaid or postpaid. Now, where did this concept of clouds come from? So cloud concepts have today, this word cloud comes from the earlier concepts of what we used to call as high throughput computing systems and high performance computing systems. HTC and HPC, these are not names of companies. These are names of technologies which used to be there earlier. So HTC systems were systems which were built using different computers to work together using something called as distributed computing concept. So we had this distributed computing concept which allowed many computers to work together to perform big tasks which a single computer cannot. So we had these high throughput computing systems which had different nodes. Disparate nodes means different machines working together. One of these aspects of these different machines working together, one of the applications or use cases became P2p networks. P2p networks means peer-to-peer networks, where many users of the internet came together to provide file sharing services like what we call as torrents today. So what is a torrent? Whatever torrent you all use, or if you have used or seen, they are basically P2P networks. They are where different machines of individuals like you and me are put together to provide file sharing. So I can share whatever files I have with you, and you can share all the files which you have with others on the network, and thereby we do a P2P network where there is no server where all the files are stored. This was started off as of originally as to share music. Then as the bandwidth increased, we are able to share videos and photos and lots of other things today, softwares and everything. Some of it is legal, some of it is not. That we'll not get into. But one of the examples of this distributed control, instead of having a centralized control, was P2P networks. On the other side, we had computing concept called as high performance computing systems, where similar nodes were put together to give very high speeds. This gave rise to what we call as clusters. Okay, so these are machines put together to work together. So I'll give you an example. When Indian Railways started their computerization of railway reservation booking, जब IRCTC की बात नहीं कर रहा हूँ, not on the internet. Earlier, the computer bookings in the 90s was started where you could go to the ticket window at VT or at Bombay Central or at Borivali or wherever, and you could book tickets which will be printed by a computer. At that time, there were 5 servers created across India, just 5. And these servers were handling the entire booking system of the entire country. Now, railways in India is the biggest network of railways in the world and carries the highest number of passengers in the world. To build a booking system like this, they needed a tremendous amount of capacity in their servers. But obviously, India being India, we didn't have the financial resources to buy supercomputers. So what they did was they took 5 alpha computers and created a cluster. So they bought 5 alpha computers which were expensive but not very expensive, and they put them into a cluster to make one big server with a single operating system running across them. So, and this such one cluster was connected to 4 other clusters. So in India, we had total of 5 such clusters of alpha servers put together, working together and handling the entire railway reservation booking of the country. And this was made possible because of clusters. And this was centralized control. So centralized control means where one machine in Borivali or Nagpur or Pune is making a reservation, but actually the reservation is happening on the server in Mumbai. So there was a server in the western region which was in Mumbai near the VT station. जहाँ पे VT station का booking होता है, वहाँ पे पीछे एक building है railways की, where this entire server was kept. So this was a centralized server and 5 such replicated उसके mirrors थे जो पूरे इंडिया में बुकिंग कर सकते. So you could book any ticket to go from anywhere to anywhere using these clusters. This clustering and distributed control systems came together to form something called as computational data grids. Computational grids and data grids were, a large scale. So instead of 5, if imagine 500 or 5,000 computers put together, the kind of processing power or data which you will be able to get from that, and that was achieved using these data grids and computational grids, which were the precursor, which were the step which was needed to move to what we call as clouds today. So grids and a grid technology was very, very useful, but for whatever reasons was not very, very popular. Finally, it gave rise to what we call as cloud computing today and clouds. Okay, cloud infrastructure. Obviously, there are other things which came out of it like IoT and Web 2.0 services, which is not part of today's discussion. Maybe some other time we will talk about Web 2.0 and 3.0 and IoT as well. Now, internet clouds came out because of the virtualization of such data grids. What is exactly virtualization? Virtualization means that we take a computer and create virtual environments from them. Okay, so there are different types of virtual environments. So normally when you use a computer, you use a physical machine. Correct? You use a physical machine where you have a hardware, you install a software, an operating system like a Windows or a Linux or a Mac, and on that you install your applications and use them. This is how you use your laptop or your computer at home, or even your mobile phone for that matter. But if we use something called as virtual architecture, there are multiple architectures. There's something called native virtual machines where we have a hardware and we install a VMM, a virtual machine monitor, which allows us to run multiple operating systems on the same hardware and run different applications on those operating systems. This is done in commercial private servers which companies or medium-sized companies or small-sized companies, when they buy a server, this is the kind of model which they use. They call it the native VM model, the native virtual machine. Some machines today, or you can do this at your home, where you can if you have used virtual machines at home to create suppose you want to do a Linux practical, then you have done what it's called as a hosted VM. A hosted VM mein kya hota hai? You have a hardware, you have an operating system like Windows or any other, and then you install a virtual box or a VMware workstation, and then install your operating system on that and use your applications. This can also be done using things like if you've used DOSBox to run Turbo C. Okay, so if you use DOSBox, it provides a virtual machine with a software which directly you can use. Or you can install an entire operating system in your virtual machine and then install the software. So that is a guest OS. So you have a host OS and a guest OS. Host OS means the machine operating system which is installed on your hardware. Then you install some VMM, which is a software which will allow you to create virtual machines with another operating system, which could be Windows or Linux or Mac or any other, and then install softwares on that. So these are the different kinds of virtual machine architectures. Now, this virtual machine architecture, whether it is native VM, hosted VM, or dual mode VM, allows us to virtualize servers in a data center. And because we are able to virtualize servers in a data center, we are able to use them from our homes as if they were connected directly to us. This image which you see on your screen right now is what we call as the hype cycle. every technology जो नया नाम आता है ना टेक्नोलॉजी में, it goes through a hype cycle. So for example, there is autonomous vehicles over here. Currently this ये थोड़ा diagram थोड़ा सा पुराना हो गया है. So autonomous vehicles now has moved up, and right now they are the most hottest thing in the world of automobile. Everybody wants to talk about autonomous vehicles. Everybody wants to talk about cloud computing and all of that. So when something becomes popular, it goes through a crazy hype where everybody wants to talk about it. Like for example, everybody's talking about data science. Once, and everybody thinks that it is going to change the entire world. Obviously, all that is expected from something does not get fulfilled, and they go towards slightly downward trend at some point of time, till it reaches a stage where people understand that what are the things which are possible and what are things which are not possible. Another example currently, which is somewhere in this region, is cryptocurrencies. So that the value of all cryptocurrencies just skyrocketed in the last few years, and now there is this correction which is happening, that suddenly people are realizing that it's going to be not only going to increase, but it can also decrease. The values can, and then there were people are trying to make understanding how to manage this volatile currency such as bitcoins, and then slowly people will become will become used to it and adopt it as something which can be used in our day-to-day lives. Okay, so for example, today we do internet micropayments. Internet micropayments means you can use your Paytm app or a Google Pay or a Phone Pay and do small transactions without having to need to use physical cash. So today, if you go to a vada pav wala, and if you buy a vada pav and if you don't have 10 rupees change, and if you have a 500 rupees note and he is not ready to give you change, he will only ask you, "Okay, sir, Paytm kar do, ya Google Pay kar do." So you can pay 10 rupees using your Google Pay app. So all these micro payments have gone on the internet today. We don't worry about carrying cash too much for small transactions at least, and that is today, because earlier people used to have a lot of a period aaya tha where people were very scared and were not using it. Okay, and now it has become to a stage where people have started interactive TV, for example, your Netflix applications and Prime Videos and Hotstar. Now there, so earlier there used to be this very big talk about Apple TV and all of that, which crashed, but now they have slowly moved up the cycle. So every technology goes through, initially from being obscure where nobody knows about it to suddenly reaching a stage where everybody is talking about it. Then it goes through a downward trend where people start bad mouthing about it, and then slowly people start understanding what are the true potentials of that technology. In cloud computing, we have infrastructure as a service, platform as a service, and software as a service as three main types of clouds, which we will be three ways in which we use clouds. Infrastructure as a service is what we call as where we host our physical infrastructure on the cloud. Platform as a service is used to build applications which will be running on a cloud platform, ready-made platform. Okay, so infrastructure as a service, the examples would be for infrastructure would be things like the IBM's Blue Cloud, okay, or Amazon Web Services virtual servers which are available for you. So if you want to buy a server today, you can go to Amazon and purchase a server, a virtual server, and then install your own operating system on it, install your own softwares on it, and run everything in the cloud. That is called as infrastructure as a cloud. You can go do that with IBM, you can do that with Amazon, you can do it with many other service providers. But if you wanted to build a website, for example, suppose you want to build a website, what you can do is you can write your code using PHP or whatever language HTML, CSS, and host your site on a GoDaddy or a Big Rock. Now, what does GoDaddy or a Big Rock provide you? It provides you a platform where it can host websites for you. So you write your own website, you create your own website, but you don't have to create your own web server. You don't have to install a web server at your home and make it available to the entire world. You may install a web server for development purpose, for trial, but then once your website is complete, once your project is done, you can install it on an online server. Okay, either it's a free server or a paid server, but they are what we call as a platform which is available. So you can directly take your PHP code and your HTML code and your CSS files and upload it. So that's a kind of platform. Now you can build not just websites, but you can build other applications. Like for example, if you want to build a mobile application, which is to be built, the server side of the code can be built and uploaded to a cloud. And such clouds are called as platform as a service. Example is Google's Google Cloud platform. Okay. Then there are others which are available, like Amazon also has a platform service provided, which is called AWS, which you can use for creating Amazon API applications. And then there are others as well. We will talk about a few. Software as a service is where you don't do anything. You have a ready-made piece of software hosted on an online server. You are directly using it. That's what you do when you use a Google Cloud, for example, to do your Google Classrooms. Your if you are using Office 365 account, then you can do Word, PowerPoint, Excel. If you're using Google, then you can use your spreadsheets and the presentations and the you can create your documents online. All of the softwares are available in the cloud. You don't have to install them on your machine at all. Okay. So if you look at what needs to be managed by a person or by a company, if you do everything on your own in traditional way or on premises, you have to create your own network, your storage, your servers, your own virtualization, buy your own operating system, middleware, runtimes, data, applications, everything had to be managed by the company itself. If you use infrastructure as a service, IaaS, you will not have to worry about the networking, storage, servers, virtualization, and operating system. All of this will be provided to you by your vendor. You will just have to install your middleware and your softwares and your data and your applications. That's it. But if you use a platform as a service, then you don't have to worry about the middleware and the runtime also. Okay, so you don't have to develop any, so you will have ready-made APIs to build your applications and store your data. But if you use software as a service, you don't have to do anything. All of your application, your data, your runtime, everything is provided by the vendor. You just have to pay a monthly fee. That's it. Now, depending on how big an organization is and what exactly do they want to do with the cloud, they can choose whether they want to use a software as a service or a platform as a service or an infrastructure as a service. The easiest to use is SaaS. The most difficult to use will be on-premises because you will have to do the entire thing on your own. Now, this is not a cloud. Infrastructure as a service will still provide you with the basic hardware virtualization so that you don't have to install or maintain your own hardware and your own networks, don't have to manage your security for these. Okay, it will be done by a third party like an Amazon or an IBM. Okay, for a platform, it could be a Google platform or it could be an AWS platform or any other. And for software as a service, as I said, there are many like Microsoft Azure, Google, many others. So we have what we call as these three types of clouds. But there is another way in which clouds can be classified. That is called as public clouds, private clouds, and hybrid clouds. Now, when I talk about public clouds, private clouds, and hybrid clouds, what is the difference? Generally, when we talk about clouds, people will talk about Dropbox, Google Drive, Google Docs. All of these are examples of public clouds, but they are more importantly examples of software as a service cloud. So public cloud means these are companies like IBM, Amazon, Salesforce, Microsoft, Google, who provide us with cloud infrastructure and maybe their own platforms or maybe their own softwares also. So In, for example, a Microsoft Azure, you will be having your own platform to build applications using Microsoft Azure technology. It will use its own data centers. Microsoft has built its own data centers where you can store all your data and your virtual machines, and you can use all of that for a subscription fee. Similarly, Amazon has done that. Salesforce. But what you are doing over there is building a using a public cloud where somebody else has the data center. Some companies are very they want to keep their data secure, or they're worried about putting it into a public cloud because of government restrictions, like banks. Banks cannot put their private data of its customers into a cloud which is outside the country. So in a data center which is outside. So what many of the banks or financial institutions will do is buy their own servers and create their own data centers, which they call as a private cloud. So this is a private cloud which can be built using some piece of software or technology provided by companies like IBM, who will help you come and build and help you build a private cloud of your own, which your employees can use from anywhere on the internet. So private cloud is owned by a single company. A public cloud is where many companies can be tenants. So they are leasing, they lease a server. It is difference between buying a house and renting a house. So the house is owned by somebody, but it is given to you on rent. That's exactly what Microsoft and Google and Amazon will be able to do for you. So that's a public cloud. When you buy your own house, it is yours, but you have to do all the maintenance. You have to manage the security. You have to do everything for yourself. That's what happens when you do a private cloud. The third option nowadays is what we call as a hybrid cloud, where companies keep some important confidential data and applications in a private cloud, but handle some of its non-very critical applications in a public cloud, so that they don't have to buy too much or do not have to maintain too much. So they use a mix of some part of private clouds and some part of their work is done in public clouds, and therefore it is called as a hybrid cloud. And hybrid cloud is something where you have a private and a public cloud working together for a single company. And such an example is of a hybrid cloud. Now, there are many cloud applications which can be done, So there are cloud applications which can be used for video editing, photograph editing, backup and recovery, storing of files and converting of files, and e-commerce applications. There are many, many out there. Some of the ones which are very popular applications include online file storage, such as, your OneDrives and your Dropboxes and your Google Drives and MediaFire and Evernote. You must be using them. Another applications which you use nowadays, but you sometimes don't think of them as cloud, is when you use a Photoshop Express or a Pixlr or a Google Photos or a Canva. What you are doing is you are editing your images in the cloud instead of editing on your software. So, pehle kya hota tha? We used to use softwares like Photoshop. Photoshop you have to install on your machine and then do the editing. Your hardware is used. Video editing nowadays can be done very quickly online using cloud, because otherwise video editing, people who have done editing of their video at home will know that it is very, very heavy process on your computer, and it takes a huge processing time of your computer. You can do that entire video processing by clicking a button in the cloud, and you don't have to worry about it. You can keep doing your other work on your computer. The process will happen in the background on the cloud. And this is being done not by just people like you and me, but by very big, studios who are making real Hollywood and Bollywood movies are now using clouds to do their video editing in, all these 4K videos and 8K videos. High resolution processing can be done far better using a cloud rather than buying all that infrastructure and keeping it with ourselves, because it's very, very expensive. So there are various cloud service providers which are out there. These are some of the ones which are the most popular ones which you should be aware of. That is Red Hat, Amazon Web Services, Microsoft Azure, Google's Cloud, IBM Cloud, Salesforce, Rackspace, and Oracle. All of these have been there for a long time. They originally maybe have had different kinds of products also, like Red Hat had its own Linux version and all of that. But now it provides Linux servers for companies ready-made as a platform, or rather as an infrastructure server. So you can use a Red Hat server without having to create or buy your own server and install and maintain that server. So does Microsoft provide applications which you can build using the Microsoft Azure. So pehle we used to learn about how to build .NET applications. Today, people don't need .NET developers, they need Azure developers. Today, people don't really need Microsoft, just to know C# or VB.NET. They want to, they will ask you in interview, can you do VB.NET or C#? Can you work with those languages on the Azure platform? That means for the cloud. If you can do that, you will be employed. It's no longer good enough to know a language like Python or Go. Can you work with an Amazon web service, or can you work with a Google Cloud? Have you ever worked with it? If yes, you will be in demand when it comes to the placement scenario. So there are various APIs which are out there, which are very, very popular. Some of the ones which APIs means application programming interfaces, which are used to develop softwares or applications for the cloud. So you don't have to build your applications in your regular C or C++ libraries. You will go mad. Even Java or something would be too complicated. There are some cloud APIs which are built for Java. There are some cloud APIs which are built in Python. There are some cloud APIs which are built in Go. Some cloud APIs which are built in .NET. Depending on which server and which service you use, you can use those APIs to build cloud services. Now, some of the APIs which are very popular include Citrix, which is an Apache project, Amazon Web Service APIs, and Ubiquitous. There is Google's Compute Engine, which allows you to build using the Google APIs. Simple Cloud, which is another API available for OpenStack API, which is another very popular API for open source platforms. So there is a lot of this debate about open source versus proprietary services. So for example, VMware and Google and Amazon are proprietary APIs. They will only work with those kind of clouds. OpenStack has created, it's a project which has been created to create clouds which are open. Open source means, like Linux is an open source operating system, OpenStack is an entire suite of applications. It's not just one single thing. It has an API, it has a cloud storage, it has infrastructure storage, it has platform. Everything has been built using open source. Okay, so it is open source, open design, open development, and an open community which will help you build applications. So if you're not very familiar with it, I would strongly suggest you go to openstack.org, and there are tutorials and videos which you can watch to learn more about how to develop applications in the OpenStack. So it provides you choice and control of what you want to use. It allows you to build very big, large-scale applications. It is not at all weak in compared to the other ones. Obviously, because it's open source technologies are gaining prominence, but yet there are these advantages which you will get by building applications in Amazon or Google, which will be much faster sometimes compared to an OpenStack. But OpenStack requires you to have a learning curve. Learning curve means thoda sa time lagta hai seekhne mein, but once you've learned it, you will have a lot of fun and developing apps and applications in an open source environment. And there's a lot of support available with OpenStack developers as well, which you might not get in other places. Even though it is open source, some of the biggest companies which you might have heard of also use OpenStack. So, for example, CERN, the biggest scientific collaboration of physics to build the LHC, the Large Hadron Collider, which is doing work on studying the subatomic particles like the Higgs boson and all of that. They are using OpenStack clouds to process huge amounts of data which is coming out of the LHC. Comcast, which is a very big company in terms of production and development, is done on OpenStack. Adobe is using OpenStack for its virtualization environment. Walmart is using it. Digital Film Tree is using it. So there are many companies who are using it for different kinds of applications, like big data, like web services, like enterprise applications, like e-commerce and development, editing, and all of that is being done on OpenStack. All right. So there are so many options and opportunities available today that if you really look at it, for the cloud, I must say the sky is the limit. So having said all of this, I hope I have been able to create a kind of an understanding of the vast topic, which is cloud computing. And I would request all of you to spend some time reading and trying to understand what this is. If there are any questions, of course, I'll be ready. I'll be happy to answer them right now. But even if there are questions which come later to you, today, everything can be answered on the internet. So ask me right now whatever you can. But even if you have any doubts, don't worry. If they come later, I'm just an email away or a message away from you all. Please feel free to do that. All right. So I think I have exceeded slightly over my time, and everybody has been very polite and not, asking me to shut up till now. So let me now just shut up and hand it over back to the organizers, and let's see if there are any Q&As which we can do. Over to you, ma'am.
Yes, sir. We have some queries. Thank you so much for a wonderful knowledge you shared with us today. One of the participants is asking, wants to know what are the career opportunities in cloud computing, and the pay scales and job profiles related to cloud computing.
Now, as I said, clouds, there are different types of, cloud in itself is a very big area. You have jobs right from cloud developers, people who will be doing development. So if you are a good programmer, you can get into the development space. If you are if you don't want to do development, yet there is a lot of opportunities available. For example, I showed you the data centers and the kind of work. They need network guys, they need security specialists, they need people who will be able to design for the cloud, they will need mobile app developers, they will need web developers, they will need designers, architects. So every kind of job role which you think in IT is today available in the cloud platform as well. So you just need to have some understanding of clouds in general, some understanding of networking, and then a little bit of programming as well. You can then choose which one you want to specialize in. So somebody can go into networking aspect of clouds, somebody can go into development aspect of clouds, somebody can go into infrastructure maintenance of clouds, somebody can go into security or the user interface development or the mobile app development or the web service application development. Even API development, developing APIs has become a very important career option nowadays for cloud, because there are lots and lots of APIs getting built. So depending on what your interest area is, you can choose. The salaries in cloud, if you are, let's say, for example, Azure developer, if you have the necessary skills to be employed as an Azure developer, you could, if you are having zero experience, but you have some understanding of Azure, you could look at 20-25,000. But if you have built a small project which is working, and if you can demonstrate that you have ability to really build applications in Azure, you could be highly sought after. And if you can build even 2 or 3 small applications while you are in college and put it up online, whether it is Azure or whether it is Google Cloud or whether it is Amazon, I don't care. If you can build a small web, instead of building a website or instead of building a mobile app, okay, जो आजकल बहुत कॉमन हो गया है, जो हर कोई बनाता है in computer science and IT students में, engineering students में, instead of doing that, if you can build even 1 or 2 small applications for the cloud, you will be highly sought after candidate when it comes to placements. Okay, so people really want people, because many of the companies, what will they do? They'll take you and then train you on cloud. But if you have some understanding, they will be love to hire such people. So if you're worried about getting a job in this kind of scenario, pandemic, don't worry. Learn to invest in yourself for the jobs of the future. Don't try to learn for the jobs of the past. Okay, so please remember, identify what are the jobs of the future, and cloud computing is the job of the future and the present.
Okay, sir. There is one more query. How is security taken care of with respect to cloud?
See, I can give you a technical answer, but let me give it to you in a very simple way. When you take money and put it in a bank, is it more secure than money in your home? So if you have 1 crore of cash, would you want to keep it at home or would you want to keep that 1 crore in a bank? Where do you think it is more safe? So if you think the majority, everybody will say in a bank, right? Everybody keeps money in the bank because it's safer there, because bank's job is to keep all of your money secure. Similarly, all these cloud platform service providers which are out there, their job is to keep your data secure. So no matter how much security you buy, it will be nothing in comparison to these service providers. So your data is far more secure in a cloud in comparison to in your home. आपके एक simple example है, Dropbox का अगर example लेंगे, your hard disk can crash anytime and you will lose all your data. But if your data is in Dropbox or in Google Drive or in OneDrive, no matter what happens to your laptop, you can go and open another laptop and access all your data at any given point of time. The data will never be lost. Okay, and they will maintain better security than you can maintain of your own computer. Believe me. Okay, so don't worry about security when it comes to cloud. These are some overhyped, fears and rumors about security.
Okay. Sir, one participant has a query. Do we have to complete cloud computing AWS architect solution certificate to get a job?
No. You need not complete the certification. If you have it, definitely it will be an advantage. But even I will suggest build an application, whether it is Amazon or whether it is Google or whether it is OpenStack. Build an application and put it online in GitHub or somewhere. Make it, publish it. Let people see it. When you go to an employer for an interview or something, give them a URL of your application and ask them to go and visit it. That will get you your job more than the certificate.
Okay, I think that's all. Any more queries? Any one of you? Yes, participants, do you have any more queries? I guess it's...
All right.
I think no more queries.
No problem.
Yeah. Thank you, sir. Thank you so much. Now I request Mamta ma'am to give the vote of thanks.
Good morning, everyone. Thank you. On behalf of SRWS and the entire fraternity of the institution, firstly, I extend my gratitude to Almighty God for making today's webinar a success. I extend a hearty word of thanks to our chief guest, Asif Rampurwala, Vice Principal of VSIT, who spared his precious time from his busy schedule to grace the occasion. Thank you, sir. Today we had an opportunity to hear your thoughts, and this is surely going to encourage us in our future endeavors. Thank you, sir, for your insights on cloud computing, making students familiar with the upcoming area of cloud computing and its applications and helping them improvise their skills. Thank you, sir. A special thanks to our respected principal, Dr. Usha Iyer, for being the guiding force behind us that stimulated us to do our best and stand tall and strong as our strength. Thank you, ma'am. With a deep sense of appreciation, I thank our staff for their untiring efforts. We have been fortunate enough to be backed by a team of very proactive and dedicated coordinators of our institution. Thank you, Suchita ma'am, Mona ma'am. I also thank Nikhil for his support. Lastly, I would thank all the participants for attending the webinar today. I'm sure this will be an add-on to your knowledge. Kindly share your feedback by clicking on the feedback button on the college website. Thank you. Thank you, one and all.
Ma'am, please.
Thank you, Asif, for the wonderful delivery and the analysis, the conceptual explanations that can really come from a stalwart who has a very good academic knowledge plus an analytical power. I bless uh, you get all the heaven's choices blessings for a very, very, very bright academic as well as a wonderful endeavor in your career. You have a long, long way to go. I maybe in times to come, I will have to see in a very academic post, which I think I'm blessing you from all the heart. And of course, all my staff members to take all those experience and brilliance from you, not only academics, administration, and in every part of the aspects where we need to learn whenever we want to do everything. You know, doing is learning. So unless we do, we don't learn. We can talk. So I'm sure you'll inspire them to do. And very soon we can have some research collaborations also. And for my dear loving students, please take the best of these people and you utilize their knowledge and take all endeavors to enhance your abilities in the areas where you have employability, scope for employability, and for wonderful career opportunities. Thank you, Asif. Thank you for sparing your time. Thank you, Suchita, Mona, Muskan, Nikhil, of course, the entire IT team and the CS team for spreading knowledge. After all, to impart is the teacher's duty. And you have tuned the lives of so many students who have listened to you today. Asif, good luck to you and God bless you all.
Thank you, ma'am, for all your blessings, ma'am. Need your blessings always.
Thank you.
Thank you, sir. Thank you
Thank
so
you,
much.
sir.
Thank you,
Thank you,
madam.
everyone.
Thank you, ma'am. Thank you, sir.
Thank you, my entire IT and CS team. Thank you, ma'am.
Thank you, Suchita.
Thank you, ma'am.